Robert, you've talked a lot about writing clean code. But what's the role of testing in all this?
Well, Andrew, unit tests are crucial. Think of them as the safety net for your code.
So, you're saying tests are just about confirming everything works as intended?
Not quite. It's more than that. Good unit tests actually help you design better code, force you to think through edge cases.
But what about testing for things that are hard to isolate? Like interactions with the operating system?
Precisely. That's where mocking comes in. You create virtual substitutes for external dependencies to isolate your code and focus your tests.
That sounds tricky. Can you give an example?
Let's say you have a function that schedules a task to run after 5 seconds. Testing that directly with the operating system's timer would be problematic. Instead, you mock the timer, giving you complete control over the test environment, knowing exactly when that function would return.
That makes sense. So you control the timing and make sure the flags are set correctly, like a mechanic checking engine components.
Exactly. It's like building a miniature model of the real-world scenario so you can test specific parts in isolation.
So, what if a test turns out to be too complicated? Isn't that a problem?
You know, testing complexity can become an issue if the tests themselves are so intricate that they end up being harder to maintain than the code they're testing.
Right. I can see how you could end up with a huge, tangled web of code.
Absolutely. That's why designing good unit tests, not just writing a lot of them, is key.
So what's the best way to balance testing effort against the time to build the product?
A good developer has a good sense of what parts of the application need most rigorous testing, and they'll prioritize those areas.
Great. Thanks for explaining this to me in a way I can understand.
My pleasure. Now let's move on to...
Yes. Hey, Rober. Thanks for joining us today. We're talking about clean code, and I've just read about these 3 laws of TDD. They sound pretty strict. What are your thoughts?
Yeah, they're powerful. It's all about writing tests first, right?
Right. But you may not write production code until you have written a failing unit test. That seems intense.
It's about creating a feedback loop. Writing a test forces you to think about the code you need before writing it.
So, you're saying it's like designing a blueprint first?
Exactly. Then you write just enough code to make the test fail. Then, just enough code to make the test pass.
That's a really tight cycle.
It is. But what's enough?
Good point. How do you decide what's enough in terms of the test before the production code?
You're only writing the minimum code needed to show the functionality that needs to be covered. You can use mock objects or specific input to create targeted failure.
So, you start really focused. That should prevent going overboard and potentially make maintaining the code easier in the long run.
Definitely. And the tests are a crucial part of understanding and maintaining the code. It's not about writing as many tests as possible, but as few as possible to verify a specific functionality.
Wow, this is fascinating. So, it's actually about quality control at every step?
Precisely. Every functionality. It's about preventing bugs in their tracks by forcing you to think about what each functionality will be doing.
What do you think about situations where tests have to evolve as the production code changes?
That's totally normal. You adapt your tests, and there are frameworks for managing the tests as you change your code. You don't need a test for everything, just enough to validate functionality and prevent regressions.
You make it sound so straightforward, but it must be hard to get right.
It takes practice. You might find it's a little slower at the beginning, but the end results often make that worth it.
Sounds like a valuable technique. Thanks for the insights, Rober. Robert, you've mentioned the crucial role of clean code, but what's the specific importance of clean test code? Is it just about neatness, or is there more to it?
It's about more than just neatness, Andrew. Think of test code as a crucial safety net. If your tests are messy, you create a trap for yourself. They become hard to maintain, and then the test suite ends up becoming a bigger liability than an asset.
So, what exactly are the negative consequences of dirty test code?
Well, imagine your production code keeps evolving. Those dirty tests become tangled and harder to change. When you need to update production, you spend much more time fixing the tests than writing the new features. Essentially, you're caught in a cycle of trying to keep up with the mess.
So, it's like a feedback loop of negativity.
Precisely. This is why it's so important to start with high-quality test design. Think test-driven development. Writing tests first can help you structure your code better and create cleaner tests from the beginning.
It sounds like a lot of effort up front. Is there a balance between quick tests and high-quality tests?
Absolutely, there's a balance. But you need to remember that the cost of fixing a problem in a dirty test suite is often much higher than the cost of writing clean tests initially.
But what if you were stuck with a dirty test suite? What's the first step to clean up?
You can start by breaking down the tests and organizing them into smaller, more manageable units. It's important to focus on structure, meaning, naming conventions.
It sounds tedious but critical. Any particular tools or techniques to help with refactoring or improving tests?
Many tools support automatic testing and integration, which can help streamline the process. These tools often have functionalities to simplify cleanup of tests and help us create clean code. Also, think about creating a style guide for your team's tests.
That way, everyone is on the same page. So it's about both the structure and the standards.
Absolutely. A consistent standard will make the test suite easy to maintain and follow for any member of the team. You need a clean approach and a systematic way of working to create maintainable test suites.
So, you're saying clean test code is not just about neatness, but about maintainability and preventing problems down the road?
Exactly, Andrew. It's about building a robust foundation for your software. It's a testament to the quality and structure of your code and of the process in building that code.
That makes sense. Thanks, Robert, for the insights. So, Robert, you've just highlighted how crucial readability is in unit tests, even more than in production code. Can you explain why that extra emphasis?
Absolutely. Unit tests are about verifying specific units of functionality. If the tests themselves are convoluted, you're essentially making it harder to understand what's supposed to happen and what went wrong if it doesn't. Clarity is paramount.
Makes sense. Listing 9 to 1, those tests seem a bit dense. What makes them hard to follow?
Well, look at all the repeated calls, the nested method calls. You've got this transformation, this fetching of a response, and ultimately the assertions. It's a lot of detail. The reader gets lost in the how and misses the what.
In the refactored version, listing 9 to 2 is a big improvement. How'd you do that?
See how the build-operate check pattern becomes immediately apparent? We break it into the build phase, the operation phase, and the check phase. That clear division simplifies the whole thing.
Makes it look almost like a procedure. I see how important those single-purpose functions are, like make pages and submit request.
Exactly. They isolate the concerns. The tests focus on the behavior, not the implementation details. You're just saying, here's the data I need, here's how I use it, here's the expected result.
So, is there a rule of thumb for what's a clean test? A checklist?
There isn't one magic bullet. It's less about rules and more about practice and experience. Start small, and keep focusing on clarity and conciseness. Always ask, can I express this more simply?
I see. It's more about keeping the focus on the test case and simplifying each step.
Exactly. And as the tests get more involved, those smaller units make sense of the overall structure.
Great insights. Thanks, Robert.
My pleasure.
So, now I'm thinking, are there tools that could help with refactoring?
Absolutely. Some IDEs have refactoring tools that help isolate and extract methods. Good testing frameworks often have built-in utilities for helping build/operate/check.
That's helpful. I'm starting to get a better feel for it. So, Robert, you're saying we can basically build our own little programming language just for writing tests?
Exactly. It's a specialized API. Think of it like a user-friendly interface, but for your tests.
So why bother? Why not just use the API directly?
Direct API use can lead to tests becoming tied to low-level details of your system.
Okay, how does that happen?
Tests become verbose, complex, and hard to maintain.
What's the benefit of making the API easier to read?
It's about readability, maintainability, and also consistency. Imagine a well-designed testing API with clear functions, rather than scattered API calls.
So, where do you start?
Often, it emerges as you refactor tests. Find the repeated patterns and abstract them out into new functions.
Could you give a real-world example?
Sure. Imagine testing a web API. Instead of directly using the HTTP library, You build functions that simulate requests and parse the responses.
That makes sense. So, is this something you do from the beginning, or do you refine later?
It often emerges over time as your tests start to become less readable and maintainable, and as you find you're repeating the same sorts of interactions over and over.
Makes sense. So, are there any common tools for helping you do this?
Several tools are available, but sometimes it's just refactoring the tests.
Cool. And how do you balance complexity and maintainability?
Careful consideration of what's being abstracted away is crucial. Keep it simple.
Thanks, Robert. That was helpful. I think I get it now.
You got it. The beauty is you gain clarity and power in your testing.
That's a nice way of putting it. Robert, so we're talking about test design, right? Single asserts versus multiple asserts in JUnit tests. What's your take?
Yeah, single assert is a common guideline. Makes tests easier to read, easier to debug. A single assertion per test function is generally a good thing.
But, what if a test needs to check multiple conditions? Doesn't that lead to multiple assertions?
Well, sometimes you just have to check multiple things. You need the test to verify that several aspects of the output are correct. The key is to minimize them.
Minimize? How does that work in practice? Can you give me an example?
Absolutely. Imagine a test that verifies an XML output. You might want to assert it's XML and that specific tags are present. Separate tests can achieve that with less duplication.
So you're saying sometimes multiple assertions are better for readability and maintenance.
Exactly. You can make the separate tests more focused on a single aspect.
So, template method could reduce this duplication, right?
Yep, the template method can really help organize that. Setting up common test conditions in a base class, then the derived classes handle the specifics.
Interesting. So there's not a hard and fast rule, just a focus on minimization, right?
Exactly. Clean code is more about judgment and contextual understanding, minimizing the asserts in a test. The number is a good guideline, but don't be afraid to break that if it leads to cleaner code.
Thanks for clarifying this. I appreciate the pragmatic approach.
Happy to help. Clean code is a journey, not a destination.
Very well put. Thanks. Hey, Robert, you got an interesting point about testing. This example in the book, listing 9 to 8, it tests a bunch of stuff, right?
Yeah, it's testing multiple scenarios for add months, but within a single function. That's a common anti-pattern.
So what's the problem with that?
It muddies the water, makes tests harder to read and understand. Imagine trying to track down a bug in a test with 10 assertions.
So, single concept per test. Why is that important?
It means each test is focused. If it fails, you immediately know what went wrong. Easier to debug.
What's a concept in this sense, though? Is it a single method call?
No, it's more about an aspect of the behavior being tested. May involve multiple method calls, as long as you only test one aspect or characteristic in the test.
So, if it involves multiple methods.
Exactly. Split up the test cases. That way, if you break down these months into distinct tests, you can see what's wrong. It's about isolation.
Say in this add months example, how might we isolate?
You'd create separate tests for cases like handling the last day of a month, or adding a certain number of months, or what happens with specific dates and months. You'd break it down, one aspect per test.
How about the risk of missing edge cases?
Well, good unit tests will still have to address corner cases, but often splitting the tests into smaller ones helps find issues.
I see. So, it's not just about fewer assertions, but understanding what each test is about.
Precisely. Clear and focused tests.
It makes sense, Robert. Thanks for the breakdown.
You're welcome. It's all about writing readable, maintainable code.
Makes testing a lot easier, right? Hey, Robert, we've been talking about clean code, and now you're diving into clean tests. Fascinating. Can you break down these FLRS.T8 characteristics for us?
Absolutely. First, fast. Quick tests are key, because you run them often. Frequent testing helps catch bugs early. Imagine a slow leak in a boat. The more often you check, the easier it is to fix.
So, faster tests equals easier bug fixes. Makes sense. And what about independent?
Tests shouldn't rely on each other. If one test fails, it shouldn't automatically crash all the others. Think of it like dominoes. A single fallen domino can't bring the whole line down.
Gotcha. Repeatable tests. What does that really mean?
They should run reliably in any environment. Same results, whether on your laptop or in production. Imagine baking a cake. The recipe works whether you use your grandmother's oven or a commercial one.
So reproducibility is essential. Now, self-validating. That sounds tricky.
Yes. The test should automatically tell you if it passed or failed. No manual log file reading.
How do we do that with tests that generate lots of output?
That's where good test frameworks come in. They handle that for you. You're just checking if the result meets expectations.
Timely tests. Interesting. Should we write them before the code they test?
Absolutely. That's test-driven development, TDD, in a nutshell. Write the test first, then the code.
Why is that better than writing the code and then writing tests?
Designing the test forces you to think about the code's intended behavior up front.
So, TDD is a way to incorporate timely tests?
Exactly. Makes the code testable from the start and makes sure you address all conditions. This is key to creating clean code overall.
So, we write the test first, then write the code to make it pass. It helps keep the code testable, right?
That's right. This iterative approach helps ensure the code is clean from the beginning.
That's super helpful, Robert. Thanks for breaking this down. Really clears up the concept of clean testing.
You're welcome, Andrew. Let's talk more about the practical applications of these principles next time.
Sounds great. So, Robert, you were saying that clean code relies heavily on good tests. Can you elaborate on that?
Absolutely. Tests are the backbone. They're as crucial as the production code itself.
How do you make sure the tests are clean, not just functional?
You make them expressive. Think of a test as a mini document describing the behavior you're checking.
Okay. How would you write an expressive test?
You'd use a domain-specific language to describe the behavior of your code.
So, like a tiny programming language?
Precisely. It cuts down on ambiguity, improves maintainability, and makes it really clear what the code is supposed to do.
But wouldn't that take extra time?
Yes, but the benefits are significant. Clean tests mean fewer bugs, easier maintenance, and more reliable code down the road.
So, you're saying writing clean tests is important even if it costs a bit more upfront?
Absolutely. It's a long-term investment in code quality.
What's an example of a test API?
In a banking application, you might have a function that validates account balances. You could have a domain-specific API function for handling test cases like checking if overdraft protection is triggered.
That seems helpful.
It helps you write more readable tests that are easier to understand.
I'm beginning to see the benefits. You're highlighting the interconnectedness of clean code and testing.
Precisely. You let the tests rot, and the production code will rot too.
Okay, makes sense. So, if I want to make a clean test, what kind of tools should I consider?
Tools to create your own testing framework can be helpful.
Excellent. Thanks for clarifying that.
You're welcome. Building clean tests is a continuous process. Embrace it.
I definitely see that now.